All right, everybody. Welcome back to another lesson in Python. So Python is an object-oriented programming language. This means that Python contains many useful classes that we can use to make objects. So, for example, there is a class called turtle. From turtle, import turtle. I've now imported the turtle class. You could see that turtle is a class because of the capital letter on classes from the turtle module. A little confusing, right? The module and the class has the same name. But now I can make turtle objects like my turtle. And we call it just like this. Okay? And that creates a turtle. Oops, I put a bracket there. And associated with this turtle are methods and variables. Most of these are methods. The turtle module actually follows a little bit more of an advanced class design where they start to kind of hide their variables. You'll see them hidden down here. So by putting these underscores, it makes them appear lower in the list because they don't suggest that you access these directly. They want you to interact through methods, which is what we've done, which is why we could try and change the color directly, but we'd have to know how to do that. It's much easier to do it through the method. And, you know, this changes my colors, my turtle's color. This moves my turtle forward. But notice again, we have the name of our object. And then we say dot the method we want to call. So this is stuff that we've seen before, but hopefully we're starting to get a little bit better of understanding. Because, like I said, Python's an object-oriented programming language, so it comes preloaded with lots of classes. Millions of classes, maybe, at least thousands, that can do some extremely advanced stuff, including, handle internet traffic to cybersecurity. There's a really robust cybersecurity module in Python. But it also allows us to make our own classes. And we've been working really hard on that. We've made classes for handling time. We've made classes for really all sorts of different things. And we've been using them and seeing how they interact with each other. But because Python is object-oriented, it also allows us to do something called subclassing. And that's when things can really start getting interesting. And it allows us to use other people's code or our own code and build on it without having to rewrite or anything like that. Or most importantly, not having to re-debug. So let's get right to it by looking at writing a class, and then we'll look at subclassing our own class. After that, we'll look at subclassing some of the classes that came with Python. So would you please make a new module, and we're going to save this module as animal subs. We probably already have, I'll clear this out so I'll retype it. You probably already have an animals module. So we'll call this animal subs so you can keep record of both for instruction purposes. All right, well, we're going to start with a little bit of a warm-up. I'm going to let you write the pet class, but let me tell you what I want the pet class to do. I want the pet class to be able to store information about the name and age of a pet. But I would also like you to make sure that you have one more instance variable called isHungry. And isHungry will be set to true when the pet is created. Okay? Then what I want you to do is to write a method called eat that sets isHungry to false and prints nom 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 nom. Okay? So let me just kind of see if I can't. I'll put it in a comment. Put some instructions there. All right. Okay. All right, so there you go. Those are the two parts. You're going to make a constructor that stores information about a name and age, and let's call the variables, self.name, self.age, and then we'll have a variable self.ishungry. Go ahead and just set that to true. Okay? Then make a method called eat, which prints nom 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 to the console and sets is hungry to false. So logically, the animal has eaten. So remember, the name of this is class pet. Working on the pet class. So class pet should be the first thing I see. I want you to take a few minutes to try that. It's okay if you don't get it 100% right, because we're going to go over it, and we'll also make sure our code and variable names agree. All right, hopefully you took a minute to try that by yourself. Let's see how we do. All right, so I've got class pet. First, I'm going to create the constructor. That's def in it. Remember, there's 2 underscores. 1, 2. And we need the word self. And that's one of the things that separates methods from functions. Methods are in a class and start with the word self to indicate that they're methods. And I want name and age. And so we could say self.name gets name. Self.age gets age. So these are temporary values. These parameters are sometimes called formal arguments, all different things. I usually use the word parameter. These parameters are temporary. They don't become permanent unless we assign them to self. That's what that does. Oops. Get rid of that. Okay. But I want you to create another one. So this is an important thing to realize. We don't have to have a parameter for every instance variable that we make. So remember, they're called instance variables because they are variables that belong to an object. And another word for an object is an instance. All right, next. I ask you to make a method called eat. And what that does is makes them not hungry anymore. If they were not hungry, they'll remain not hungry. And we'll print nom nom nom. Okay. All right, that's it. That's the pet class in all its glory. Let's go ahead and do a quick run. It's always important to check things as you go. So just run your module right quick, and we can create a pet object now. So remember, to create an object, you say the name of the class, then parentheses, and you need something in parentheses for every parameter after self. So I need something for the name. And one of the things I like to do is to put the dot and then press the tab key, and it brings up a list of different options. So it's a nice way to check that of what you have available. And you can see that I have age and eat, is hungry, and name. Now age and is hungry and name are all variables. They're not methods. Notice that I do not have to put parentheses after them, and that's because they are variables. Now, if I say eat and don't put parentheses, it'll tell me that that's a method. So it tells me what it is, but it doesn't actually run it. I have to put parentheses, and again, anything I have beyond self, I need something in there. I don't need anything because all I have is self. So this should do that, and then we can check is hungry again, and that should now be false. Okay, so that's by way of review. The next thing we're going to do is we're going to make another class. And this class is going to be what's called a subclass. Let me just get rid of that. So, first of all, I want to just discuss kind of the way this is pictured in class diagrams. So currently, we have a class called pet. And what we're going to do is we're actually going to make a couple different subclasses. I'm going to show an arrow, and we're going to make another class called dog. And We've talked about has a, like a pet has a name. A pet has an age, and also a pet has a hungry variable and is hungry. But now we get to talk about another important phrase called is a. A dog is a pet. And what's going to happen is all this code here is going to be automatically assigned to any dog. And let me show you how that works out. So class dog, and I would like this to subclass, so I have to tell Python. This is the syntax to how to tell Python to do that. It looks like I'm calling some sort of method called dog, but it's a little bit clumsy of a syntax, but that's how you say this class is a subclass of pet. And I think a dog can do more than just eat. A dog can fetch. Or at least some dogs can. So I'm going to say fetch, and this is going to say woof, woof. And then how about run, run? So they bark a couple times and then run. All right. But when you play fetch with a dog, it gets hungry. So this is a little weird. Self.is hungry. Where did I declare that variable? Well, it already exists. It was constructed up here. And class dog inherits all of this stuff. Let me show you how that works. So I'm going to say D for my dog. Now, I need to give my dog a name. And an age. Why does my dog need a name and an age? Because it's a pet. Pets require names and ages. Okay, so let's take a look at dog. So D.tab brings up all the things. Notice, just as we expect, age, eat, is hungry, name, all those things from pet. But look, I've also got fetch. I've also got fetch. Now, you'll notice my dog is hungry, so my dog's going to eat. Now, is my dog hungry again? After eating? Should not be hungry, right? So it's now false again that my dog is hungry. Not true anymore, right? Because I just fed my dog. But, zoom up a little bit, get more in the middle of the screen. But I'm going to play fetch with my dog again. Remember, the name of my dog, the variable name is D. And now it's probably hungry again, right? Became true again that the dog is hungry, so then I can eat. So you see that we were able to add to our class. We didn't have to redo any of this. We just said, hey, I want to make a dog class. It has a lot of the same things as pet, just with a little more specificity. In general, that's the way we're going to design our classes. You start with the most general class. Maybe if you were doing a geometry assignment, you might start with like a polygon. And then maybe subclass that with a quadrilateral. And then subclass that with a parallelogram. And then subclass that with a rectangle. And then subclass that with a square. And you could have different branches off. You might have parallelogram subclassed by rhombus and by rectangle. Because all those different things that described it before is still true. You're just adding more stuff. So it's true that every dog is a pet. It's not true that every pet is a dog, right? So let's make a pet this time. Named Kitty, that's 3 years old. And I can definitely eat. But if I try and fetch, that doesn't work because it's not a dog, it's a pet. And while every dog is a pet, not every pet is a dog. Okay, now, we're going to do something else. We're going to write a method in the dog class that already exists in the pet class. We're going to see what that does. And my dog wags its tail when you feed it. So let's run that. So the only change that we've done is that I have added another method to the dog class called eat. So I'm going to say D equals dog, and I'll call it Solomon, my dog. Now, here's the question. If I say D.eat, what will it do? Will it do the nom 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 or the wag wag wag? And, programming is written in a way that should make logical sense. It should be the way you expect. And I hope you agree that because I wrote eat in the dog class, I am telling Python, I know I want you to do this instead. So that is called overriding. And it's a good habit to actually mention that with a comment. That we are overriding a method. We're saying, hey, I know this method is already done for me, but I actually want to change it, okay? Now, there is a problem with my eat, though, because check it out. I've got this dog. The dog is hungry. And then I eat, and the dog is still hungry. And so I don't, we could just set self-dot is hungry to false here, but I want to pretend that there was a lot of code here. Perhaps even code that I don't know how to do, or I wouldn't know how to do without reading a lot. For the most part, I really want to stay away from directly accessing these variables. But what I want to do is I want to use the eat from the super class. This is called a subclass. This is called the superclass. Okay? So remember, this is super, or sometimes called parent class, and this is the subclass. So if I want to also get the logic from the superclass, call the super function. And what that does is it says to Python, hey, I want you to give me direct access to the superclass. And I'll say super.eat. So when I call eat, it will call superclass eat, go up here, set is hungry to false, print nom 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 nom, then it will come back and print wag wag wag. So let's see how that works. So currently we're hungry. I eat, and notice the nom 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 came first because I called super.eat here. So that's going to go up here, do that code, then come back and print wag wag wag. If we change the order in which that occurs, I don't want to debug. Anyway, change the order. Then we see wag, wag, wag occur first, then nom, nom, nom. Either way, what we get the logic that we were looking for, and that is hungry is now false. However, I try to stay away from this for the most part in my CS1 classes. But that's typically not a good idea for reasons I don't want to go into. If you're going to call super, I think it's usually best to do it first. So that's just kind of the way that goes. You can do it second in Python. If you have a good reason to, that's fine. But usually you want, most part we want our calls to super first because we want that done first. All right, so we are just learning a lot. We have seen how to write a subclass by adding the word of the name of the class we want to make our parent class. We've seen how to add new methods, and we saw how to override them. So what I'd like you to do now for an exercise is I want you to make another subclass. I want you to make the subclass cat. And cat is going to have one additional method, not variable, a method called chase laser. Now, chase laser makes the cat hungry. So that's going to make the cat hungry again. And will print out death to laser pointer. Got it? So I will copy that over as a little bit of a comment so you have something to look at if you're pausing the video with me. Okay. All right. I got to go all the way over here. Hold on. Okay. Oh, yeah. One more method, actually. I want you to override eat. So we're going to override eat. I'll add that to my little diagram here. Override eat. And the override eat method, I want you to call the superclasses eat method, but also print chomp, chomp, hack, because we all know cats can't eat without hacking up something. All right. Give it a try. All right, here we go. We are going to write a class for pet, a subclass of pet called cat. So we just, I'm in the same module here. Class cat. Subclass is pet. We're going to add a method called chase laser. If you throw a laser pointer on the ground, cats will chase after it. That's super fun. We're going to print death to laser pointer because they get very vicious with the laser pointer. And we will go ahead and set self.isHungry to true. And I also ask you to subclass override the eat method. We'll call the super eat method so we still get all the logic from there. But we're going to also print chomp, chomp, hack. All right. Let's test it out. Make sure that we got what we want. And then we're going to learn one more bit of thing before we get to see a cool application for this. So I'm going to make a cat. That's right. I have like a 5-year-old cat, the same name as the vice president now. So that's kind of my claim to fame. C dot. You see, we got all that stuff that we've inherited from pet, of course. We don't have fetch, but we do have chase laser now. And we can also eat, just as you expect. So hopefully you had success with that. The next thing we're going to do is we're going to look at how to subclass with overriding a very important method called a constructor. And we need to be super careful when we override a constructor. So I'll tell you what, let's make another module. Let's keep this one just for reference. I think that'd be a good thing for you to be able to reference back to. We'll make another module, and I'm just going to call this vehicle. And I'll probably, do some assignments. We'll do some assignments with it. Maybe not in this lesson, but we'll do some more work on that after today. But I felt like this would be a nice way to demonstrate this. So first I'm going to write a class called car. So I need a constructor. That's the init. And my car is going to have 2 instance variables, wheels and mileage. But the default number of wheels is going to be 4. And the default mileage will be 0. When you get a new car, typically the mileage is at least close to 0, right? So this is like a new car. So remember, we have these ability to make our variables have default values. They need to be the last in the order that you list these parameters, okay? So by doing this, we're going to allow the users to make a car and set the wheels, or they can just accept the default number of wheels being 4. And we're going to make our drive method. And I just wanted to say, you can make it say vroom vroom if you want. I think that'd be good. And but I'm just going to have it print out that we drove this many. Car drives that many miles, or I should probably say vehicle. All right, and then I'm going to keep track of the mileage, so I'm going to increase it by the miles driven. Plus equals to increase, okay? And, let's go ahead and check that right quick, make sure we don't have any major errors. And that gives us another chance to confirm that it's a 4-wheel vehicle with mileage 0. You see I got drive, mileage, and wheels. Wheels are 4. Mileage. Oh, because I misspelled mileage here. All right, well, whatever. All right, but this time I want to make a car that let's say that the car has. We'll leave the wheels at 0 at 4, but we're gonna say mileage equals 1,000. We could also try in something like this, but then which one is that? Is that wheels or is that mileage, right? Well, you'll notice that it goes in for mileage because actually it goes in for none because I didn't know which one to put it in. Never mind. But with C, since I told it, okay. Oh, you know what? There's the problem. I put 4 and 0 here. How'd y'all let me do that? It's hard to code and talk at the same time. I was going to say, wait, why is it still 4 and 0? All right, let's try that again. 1,000. Yeah, there we go. Wheels 4. Now, if I try and just do that, like, let's say 2,000, which one does it go for? Ah. Yeah, so it went for the first one, if I give it 2, like maybe it's got like 2 wheels, like it's a motorcycle car, I don't know. Then it will figure it out. But that's why it's typically, you'll see that we like to label it, okay? When we do that. That's the Python sort of way to do that. That's kind of a unique feature of Python that we can do that. So yeah, there's our default values for these variables, and yet it still gives us a chance to change them. It makes making a car super easy that we can just say that. Okay, well, for some reason the word mileage is just impossible to spell. It's been pointed out to me that I misspelled there. So, thank you. I'm going to have to restart it, though. But I want to show you how that drive works. Let's say C is equal to car. We know that C.mileage is 0. But if I do drive, notice I've got a parameter here because I got miles. Got something beyond just the word self. So, I'll drive 30 miles. And it keeps track of it. If I drive like another 5 miles, it's our odometer. You see now it's 35. So there we go. Okay, now suppose we want to subclass this with a gasoline car. Okay, so you can imagine we might have an electric vehicle, but we're going to do a gasoline car here. And the problem, though, is I have a couple more instance variables that I need to include. So I need to go ahead and write the init here because I want to add capacity and miles per gallon to this list. So I'll say self dot fuel capacity is equal to capacity. So yeah, I just put capacity here, but I'm going to spell it out as fuel capacity. Self dot miles per gallon. And I'm also going to make self dot the amount of fuel. And I will start with the car filled up. So we'll start with a car full of gasoline. All right. I'll go ahead and run this now. And I'm going to say G equals gasoline car. Let's give it a 20-mile tank and 30 miles per gallon. And I'm going to say G.drive. Oops, miles. G.drive, 20 miles. Whoops. What happened? Now, you'll notice it had a drive, right? It said vehicle drove 30 miles. But look what happened. Self.mileage plus equals miles attribute area gasoline car object has no attribute mileage. Sure it does. It's right here. We made mileage in the constructor for car. But do you realize the error of our ways? What happened? When I went down here and wrote this, I overrode the constructor. My gasoline car, if I check its attributes, you're going to notice I don't have wheels or mileage. So, for that reason, we need to add a call to super. So we're going to say super dot underscore underscore init underscore underscore. And the nice thing is that we have these default variables. If I didn't have them, I'd have to put in values here. Or maybe even take them in my initializer, my constructor for gasoline car, and then pass them through. We'll see more of that later. Now, it should work. So very common, if you ever want to write a constructor for a subclass, you're going to see the very first line, and it should be the first line typically, super, called the super function, dot init. So super parentheses tells Python, I want you to go to the super class, and then this is what I want you to do. So now, okay. How is it missing two positional arguments? But they're optional. Oh, no, I'm missing mine. Capacity to MPG. My bad. Don't look at that. That didn't happen. I was thinking I didn't need them because they're optional, but I do have required capacity. So we'll do 20 gallons and we'll do 30 miles per gallon again. All right, that's better. And again, that dot tab, I love that. I could see what I've got. There's my drive method. There's my amount of fuel, my fuel capacity, mileage, and wheels finally. So that means our drive method will work. Okay, I forgot how many miles. All right, we're going to drive 30 miles. Yeah, so it works now, and that's important. When you write a constructor for a subclass, you might be causing serious damage to how other methods work. So even if you're not sure you need it, if you write an init in a subclass, include this line of code. It just helps. Okay. One more thing I want to point out: even though wheels and miles were default parameters, they had default values, they still did not get assigned because we did not call init. So the super init. So even when they're default, you must call super init. So what I'm going to do is I'm going to give you one more little activity, and then we're going to look at something just for fun. I'm going to ask you to write this method. It's going to be an override. So self miles. And what I want you to do is I want you to correctly calculate the amount of fuel left in the car. We can just assume that the car has enough fuel, otherwise it'll go negative, but just for simplicity, assume it has enough fuel. I want you to adjust the fuel level of the car, the gasoline car, based on the miles that are driven. Now, fuel capacity, you shouldn't be touching. That fuel capacity just sets how much fuel is in it when you fill up. So we would use that in a fill-up method. But I want you to adjust to decrease the fuel by the proper amount. Now, this is the variable you'll need to be using. This is miles per gallon. It indicates how many miles you can go on each gallon. So, for example, if you can go 20 miles per gallon and you drive for 20 miles, you'll use 1 gallon. 40 miles, you'll use 2. So from there, I think maybe you can see the pattern and figure out the math on how to do that. So I'm going to pause the video and you give it a try. But don't forget to call SuperDrive in your override, because we need that as well to add the miles, keep track of our mileage. Don't want the odometer broken. All right, so first off, and again, we don't have to, but I think it's a good idea to call Super if you need to at the beginning of your overridden method. So we're going to call super.drive and we'll send it the miles. And then my request was that you were to decrease the fuel in the vehicle. By how much? Well, if you notice in my example, if you think about 10 miles per gallon. If you drive 10 miles, that's 1 gallon. If you drive 20 miles, that's 2 gallons, because 20 divided by 10. So I'm going to take the miles that I drove, and I'm going to divide it by my miles per gallon. So again, if your miles per gallon was 20 miles per gallon and you drove 60 miles, you could expect that you used up 3 gallons of gas, because 60 divided by 20 is 3. While we're here, let's go ahead and do one more method. Let's do fill up. And when we fill up, our self.fuel goes back to capacity. So you can see we have self.fuel gets set back to our fuel capacity. We could take a parameter for how much gas you want to put in it, but let's just assume that we want to fill the car all the way up to filled up. Full fuel capacity. Okay, so let's test out our drive method. So I'll make a car, and I'll drive. Oh, maybe drive a little bit more, right? Now our mileage should be accurate because we're calling the super. But our fuel should be, we've lost some fuel, right? Because we drove, right? But maybe we want to fill up. So I'll call fill up. And now our fuel is back to the full 20 gallons, which was our capacity. If we drive for like 200 miles, then now we're really getting some mileage. Still can't spell mileage. And how much fuel do we have? Well, quite a bit less, right? We can add some more logic there, like maybe make the miles only drive as far as your fuel would allow you to, and not let the fuel go in the negative or something like that, because you can't have negative amount of fuel. But we'll call that done for now. We might come back to that though. But at this time, I'm going to share. We're going to end this lesson with something cool. I promise something cool, and here it is. So, doesn't really matter where you do this, but I think you're probably going to want these, and we're going to come back and add an electric vehicle in an assignment later. So let's just go ahead and make one more new module, and we're going to call this module Funky, Funky. Now, this is actually, although it's just something fun, this does show an important thing. We don't have to subclass classes that are in the module we're working. As long as we import a class, we can subclass anything, right? So obviously I'm not in the turtle module, but from the turtle module, I want to import the turtle class. So now I've imported the turtle class, and I'm going to make my own class called Funky Turtle. And Funky Turtle will subclass Turtle. Now, this is a pretty powerful statement. The turtle module, if you open it, is something like 12,000 lines of code long. It has a lot of stuff in it. It's got vector work, lots of math work. I mean, it's a lot to that class. Even if it is an educational kind of class, that's a pretty advanced, amount of coding there. But we just inherited it all. I'm going to make a constructor. And as we learned, if I don't call the super constructor, my funky turtle will no longer be a turtle. It just won't work right. So we're going to have to do that. We're going to say super and then underscore init, and that's going to help. Now, I'm going to call some different methods. I'm going to say self.shape turtle. So self is myself. The shape method belongs to the turtle class. It's going to set myself to a turtle shape that I like. And I'm also going to set my color. So my funky turtles are always purple and they're always turtles. So remember originally when you make a funky turtle, it comes out like a black arrow, but this time it's going to be a purple turtle. But this turtle is cool because we're going to override forward. Remember, I need self, and then I'll say amount. And if we're going to override the forward command, we need to make sure that it still works nicely. So I'm going to say super dot forward and send the amount I want to go. So when we call forward, it'll go to the turtle module's forward, the one that Python wrote for us, the creators of Python. But then we're going to do a 360 in both directions. So after our turtle moves forward, because our turtle is a funky turtle, it's going to do a little dance. All right? Let's run it. Oh, I misspelled init. We need 2 more here. There we go. Let's make sure we fix that. Thank you. And we'll run it. And I'm going to make a funky turtle. Call him FT. Funky turtle. And you'll notice it brings up, just like we're used to, the Python graphics window. I'm going to try and make it to where I can see both at the same time, and that may not be possible. I think I got it. There we go. So there's my turtle, and I'm going to make my turtle turn left to show you that I can. All right. But now I'm going to say ft.forward. And let's go forward 100. Oh, it's a funky turtle. For I in range 44, we'll make a little square. We're going to go ft, my funky turtle forward, 100, ft.right, 90. Oh, funky turtle, go funky turtle. Isn't that cool? That's the cool thing I've been talking about, rewarding you for all your hard work today. So if you didn't think that was cool, well, sorry. Okay, that's it for this lesson. So we'll just spend the rest of the time doing, finishing up our stuff that's due.